Lesson 2.7 is kind of a big lesson, so we're going to break it up into two parts. And the first part of 2.7 is we're going to cover what's called a piecewise function. So a piecewise function is really just a function that in the middle of its domain switches to a different function. And it can do this for a couple of different sections. But first we're going to evaluate a piecewise function. So what you see at the top of this problem, f of x equals, that is the function itself. And what it's telling you is that if your x's are less than or equal to 4, then your function behaves as a 3x minus 1. But if your function has an x greater than 4, it's going to behave as a 2x plus 7. So they're both lines, but they're definitely lines that look very, very different. So our first problem says evaluate it when x equals 10. Well, we have to ask ourselves, if x is 10, should I be using the top function or the bottom function? And it says to use the top function if your x's are less than 4, bottom if your x's are greater than 4. So since we're greater than 4, we're going to use the bottom function. And let's go ahead and substitute that 10 in. So 2 times 10 plus 7 gives us a 27. So for number 2, x is negative 1/3. We have to figure out if we're supposed to use the top or the bottom function. And since negative 1/3 is less than 4, we're going to use the top function. So our top function says 3 times our x, which is negative 1/3, minus 1, and that will give us a negative 2. Okay, number 3 says x equals 4. Now it says to use the top function if your x's are less than or equal to 4, and since we're equal to 4 this time, we're still going to use the top function. So 3 times the 4 minus 1 gives us an 11. X equals negative 2. Again, we're still going to use the top function because that is smaller than 4. So we're going to say 3 times negative 2 minus 1 gives us a negative 7. And then x equals 5.2. That's bigger than 4, so we're going to use the bottom function. So 2 times 5.2 plus 7. And we end up with a 17.4. So once you figure out whether you're supposed to use the top or the bottom function, this is a really easy problem. Next, we have 3 different functions. We have f, g, and h, and you're going to notice the first 4 problems are always evaluating at function f. So we're always going to be using this function right here. Now function f is kind of unique. His splitting point is when x is either less than or equal to 0 or greater than 0. But if you notice, the functions themselves are kind of strange. The top function is a 3, and the bottom function is a 2. There's no variables in these problems. These are constant functions. So our answers in these first 4 problems will either be a 3 or a 2, depending on whether we're greater than or less than 0. So f of 2, if it says we are greater than 0, we're supposed to be using the bottom function. And since we're using the bottom function, normally I'd say plug in the 2, but there's nothing to plug in, so the answer is 2, the bottom function. F of negative 4, we should be using the top function because that's less than 0. So normally I would say substitute in the 3, but it's, or negative 4, but it's always a 3. F of 0, since it is equal to 0, again we have to use the top function, so it's going to come out to a 3. And then 1/2 is greater than 0, so that would be the bottom function, and that would be a 2. Okay, this time the next row of problems is all referring to the function g. Well, this time g has a splitting point at 3. If you're less than or equal to 3, you're going to use the function x plus 5. And if you are greater than 3, you're going to use the function 2x minus 1. So when I start with g of 7, that is greater than 3. So we're going to use the function 2x minus 1. So 2 times 7 minus 1 is 13. Okay, g of 0, that would be less than 3, so we're going to use the top function this time. So we're going to use x plus 5. So 0 plus 5, which is a 5. G of negative 1, again, is less than 3, so the top function says x plus 5, or 4. And then g of 3, when we're equal to 3, again we use the top function. So 3 plus 5 gives me an 8. Moving on to the next 3 problems. This time we're talking always about the function h. And there's the splitting point for h is at -2. If we're less than or equal to -2, we're supposed to be using the function 1/2 x minus 4, excuse me. And then if we're greater than -2, we're supposed to use the function 3 minus 2x. So when I look at h of -4, that is less than -2, so we'll be using the top function. So 1/2 times the x minus 4, which gives me a -6. h of -2, when we're equal to -2, we're supposed to be using the top function. So 1/2 times -2 minus 4, let's see, it gives me a -5. h of -1, -1 is greater, so I'm going to use the bottom function, 3 minus 2 times the x value, so that comes out to a 5. And then h of 6 is also greater than -2, so bottom function again, 3 minus 2 times the 6, which is -9. So that's evaluating piecewise functions. Now we're going to talk about graphing. So our first function is splitting off at the x value of 1. So the first thing I like to do is kind of draw a boundary line in on my graph. Now forgive me if this does not turn out so pretty. You can use a colored marker or a colored pencil or some other color. Draw a little dash line in here at x equals 1. Sorry, it's hard to do on my slate. And this is not actually part of the graph, it's just going to help me realize this is where my function splits off. And we're going to start by looking at the top function. The top function says if x is less than or equal to 1, use the function 2x minus 1. So first thing I'm going to have you do is draw a closed circle, because this equal to bar means that on the boundary line of 1, we're going to have a closed circle. Okay, now what I want you to do is come up with the ordered pair that'll start my function at that boundary line. Well, I know my x value is 1 at that boundary line. Now if you take that 1 and you go ahead and plug it into that top function, 2 times 1 minus 1, so 2 times 1 minus 1 gives you a 1, and that's how I'm coming up with this other y value. So at 1, 1, we're going to draw a closed circle, and that's the starting point for this top function, 2x minus 1. Now we're only supposed to graph this function if my x's are less than or equal to 1. Now there's two ways to continue this graph. You could either continue a t-table, where you choose another value that's less than or equal to 1, or you could graph however your slope is indicating. So I'm going to talk to you first about slope. The slope of this graph, 2x minus 1, is the 2. So normally, if you were graphing something that had a slope of 2, you would travel up 2 units and right 1. But unfortunately, this function only exists if your x's are less than 1. So instead of traveling up 2 and right 1, you could travel down 2 and left 1. And that's, oops, how we can graph that. Now, if you didn't quite follow that, the other way to do this is to have your little t-table, and remember we had our first point at 1, 1. Now if I picked another value where my x was less than 1, I'm going to pick a 0, because that is a number that is smaller than 1. If I plugged it in to 2 times x minus 1, I'd get 2 times 0 minus 1, which gives me a -1. And if I plot the point at 0, -1, and then connect them, you're going to see that same half function. So whichever way you would like to graph this is totally fine. The next part of the problem, is when my x's are greater than 1. So I'm going to say the bottom function is going to have an open circle on the boundary line. And when I go ahead and plug in that boundary line number, 3 times 1 plus 1, so I'm plugging this number in right here. 3 times 1 plus 1 gives me a 4. So at the point 1, 4, I'm going to have an open circle. And then here you could either graph your slope. You should notice your slope on this line is a 3. So you can travel 1, 2, 3, up 3, right, 1. And since it said stay greater than 1, that we're on the right side. Whoops. Now, if you didn't follow that, you could continue and make another little t-table for this bottom function. We already had the point 1, 4. And then if I picked something greater than 1, I'm just going to pick a 2. 3 times 2 plus 1 gives me a 7. So when I plotted the point 2, 7, which is right there, I'm going to end up with the same half function. So that's what a piecewise function is going to look like. It's going to split on some boundary line. It's going to look really weird. It does help if you do this in 2 different colors. Okay, the next function, 1/2 x if your x's are less than 1, and negative x plus 3 if your x's are greater than or equal to 1. So again, I'm going to draw in a little boundary line. Ooh. Hello. Let's erase those wrong ones. Alright, so I think I'm going to use the t-table method on this problem. I think that works best for most children. So this top function here, first of all, I notice it's going to have an open circle at x equals 1. And the reason I notice is because it doesn't have an equal to bar. So when I go ahead and plug in the 1, I get 1/2 times 1, which is 1/2. So I'm going to graph an open circle at 1, 1/2. That's kind of hard to do, but it's right there. Now, I need to graph something that is smaller than 1. So I like to choose just the next number in line, so 0. If I plug in a 0 to this top function, I get 0, 0. So at 0, 0, draw a point. This time it's not an open circle. Anything off of the boundary line will always be a solid point. And then we're going to go ahead and graph that in. Okay, let's do the same thing for our bottom function. I'm going to make myself a little t-table. If I plug in a solid circle for the boundary line, if I plug in a 1, I get negative 1 plus 3, which is a 2. And then I have to pick something to the right or bigger than 1, so I'm going to pick a 2. If I plug that in, I get negative 2 plus 3, which is a 1. So at the point 2, 1, I have another point. I'm going to go ahead and connect these pieces. And there's your piecewise function. It's very important you watch out where an open circle and a closed circle are located. Okay, number 15. We have a top function and a bottom function. So the top function, they both split off at 3. I guess I should draw that in. You don't have to draw the boundary line in. It's definitely not part of the graph, but it helps me. So for my top function, I'm going to move this over here. We're going to have an open circle at 3, and when I go ahead and plug in the number 3, 3 plus 2 gives me a 5. So at 3, 5, I have an open circle. Now I need to pick numbers careful. This time it says greater than 3. So a number greater than 3 would be a 4. So if I plug in a 4, 4 plus 2 gives me a 6. So at 4, 6 is my next point. And I'm just going to do my best to connect those. So notice this time the top function branched off to the right. Sometimes they switch it up on you. The next function has a closed circle on the boundary line of 3. And when I plug in a 3, I get 3 minus 3, which is 0. And then this time I want to choose numbers that are less than or equal to 3. So a number less than 3 would be the number 2. If I plug in a 2, 2 minus 3 is a negative 1. So at the point 2, negative 1, let's draw another point. And then go ahead and connect. And there you go. Okay, our next function. Same idea, except this time our boundary line is at 1. So, oh geez, let's erase that. Okay, top function is over here. So we're going to have a closed circle on the boundary line. And when I plug in the 1, 1 times 2 gives me a 2. And I want to choose numbers careful, smaller than 1. So if I choose a number smaller, let's choose 0. 2 times 0 gives me 0. And then connect. Oh geez, that was terrible. Try again. Hopefully you guys are having an easier time graphing than I am. Oh my goodness, that's the worst. Alright, pretend that went through this point right here. The next function, the bottom function, t-table. We're going to have an open circle this time on the boundary line. When I plug in a 1, 1/2 times 1 plus 2 gives me 2.5 or 2.5. So at 1, 2.5 we have an open circle. And then I want to choose numbers greater than 1, so I'm going to choose a 2. And when I plug in a 2, 2 times 1/2 plus 2, let's see, that'd be 1 plus 2, so it's a 3. So at 2, 3, draw my next point. Oy. Okay, I didn't do a very good job of graphing that, so hopefully you can use your imagination as what that's supposed to look like. Our next problem has a boundary line right at 0. So, a little hard to highlight it, but there he is. Oh, jeez. Alright, so for our top function, we're going to have a closed circle on the boundary line at 0. And when I plug in a 0, whoops, back up. When I plug in a 0, I get 0 plus 3 or 3. So at 0, 3 we have a closed circle. Now for the top function I want to pick numbers that are smaller than 0. So the next number smaller I'm going to choose a -1. -1 plus 3 gives me a 2. So at -1, 2 I've got a closed circle. There you go. Now for my bottom function, I have an open circle on the boundary line, so 0. When I plug in a 0, I get 0. Oops, that was supposed to be open, wasn't it? Try again. Now, my next point, I need to pick something greater than 0, so I'm going to pick a 1. 1 plugged into the bottom function gives me a 2. So at 1, 2, that's my next ordered pair for this blue function. Again, my graphing's not going so well. Hopefully yours is better. And that's number 17. Okay, number 18. Boundary line at 2. So, there he is. For my top function, I'm going to have an open circle on the boundary line, because it's not equal to. 2 minus 3 gives me a -1. So let's do an open circle at 2, -1. And then if I pick something less than 2, that would be the number 1. 1 minus 3 is a -2. So at the point 1, -2, I have my next ordered pair. Okay, for my bottom function, this time I'll have a closed circle on the boundary. And when I plug in a 2, something kind of strange happens. 1 minus 2 gives me a -1. So even though I already have an open circle here at 2, -1, I'm going to cover it up with my new closed circle. And then I need to pick something greater than 2 this time. So if I choose a 3, 1 minus 3 gives us a -2. So at 3, -2, you get the next part of the blue function. And we end up with this lovely, what's really called an absolute value graph. And we'll talk about more of these types of graphs 2 lessons from now. So that concludes lesson 2.7 part 1.